If you were to be given an expression such as 5 times parentheses 2 plus 4, you would immediately think of PEMDAS, your order of operations, and say that, well, I'm going to do my parentheses first, so I'm going to have 5 times 2 plus 4 inside the parentheses of the math adds up to 6. Now after I do my parentheses, I look for exponents. There are no exponents, so I do my multiplication, and 5 times 6 is 30. That's very easy to do problems. But imagine that instead of given just integer values, you now have variables. I can't add 4x and negative 7 because these are not like terms. So PEMDAS fails me at this point. I need to have a new strategy. This new strategy is the distributive property. If we imagine here, if I distribute, this is 5 times 2 and 5 times 4. So this is 5 times 2 is 10. And I'm going to add to that 5 times 4, which is 20. 20 plus 10 is 30. You can see that the distributive property, when I multiply the first term together and the first terms times the last term together, I distribute the 5 to each term inside, I still get the same answer out. So the distributive property can be shown in this example to work. Now let's use it with variables. So if I have 3x squared times 4x minus 7, I'm going to distribute my 3x squared to the 4x. 3x squared times 4x, and then I'm going to distribute my 3x squared times the negative 7. So this is going to be negative 3x squared times 7. 3 times 4, I multiply my integer values together to get 12. X squared times x, that's the same base being multiplied, so I add the exponents. 2 plus my invisible 1 gives me 3. Bring down my negative sign. Integer values multiplied together, 3 times 7 gives me 21, and x squared is still there. Now here I have a monomial times a trinomial. This is called a trinomial because there are 1, 2, 3 terms. Tri stands for 3, like a tricycle. So I take my 4x, my monomial out front, and I multiply it by 2x to the 5th. I distribute it. So I have 4x times 2x to the 5th. I add to that my 4x being distributed to my negative 5x. So I have 4x times negative 5x. And I'm going to continue to distribute my 4x times the last term. So I add 4x times 6. I then go ahead and simplify each term. 4 times 2 is 8. X times x to the 5th is x to the 6th. Bring down my addition sign, but then I realize that, oh, I've got a positive times a negative, so I'm actually going to have a negative. 4 times 5 is 20. X times x is x squared plus 4x 6, so that's 4 times 6 is 24, and the x.